So we've looked at the polynomial division method where we're using the bus stop method, and when I was first taught to do this, I learned it by a completely different method, which I still like, and one of my main reasons for liking it is I can see exactly what's going on. I don't have to think at all about what's happening in the stages. I can see. And what surprised me when I started teaching this topic a good few years ago is that I went to my first class and said, look, there's a method in the textbook, but don't worry about that because here's a much better method. And I showed the class both methods, and everybody liked the method in the textbook. Everybody liked the polynomial division with the bus stop method, and that seems to be the case. Most people prefer that method. I don't understand why. I prefer this method, so maybe you're like me, maybe you prefer this method, so here it is for you to see as well. So let's go back to the question that we had. We wanted to do x cubed plus 2x squared minus 17x plus 6, and we wanted to divide that by x minus 3, okay? Well, what we're going to do is we're going to say, well, that division is the same as x minus 3. We're going to think of that division as a multiplication instead. X minus 3 times something equals x cubed plus 2x squared minus 17x plus 6, okay? Now, we know that this thing here is going to be a quadratic, because if I do a quadratic times a linear term, I'm going to get a cubic. But let's go the whole way. I don't know if there's going to be a remainder or not. So I'm going to stick in an extra number as well, a remainder as well. So this is what it's going to look like. I don't know what my quadratic is, but it's going to look something like this. ax squared plus bx plus c, and I'm just using capitals here, just so that I don't confuse it with it being a sort of a general quadratic. And then I'm going to say, okay, well, there could be a remainder, so there could be a constant out here, which I'll call d as well, okay? Now, if I can find a, b, c, and d that make this equation balance, then I'm done, right? In fact, it's not an equation, it's an identity. If I can find an a, b, c, and d so that this side is the same as this side, but a factorized version of it, then that's what I need, right? So this is how we're going to go about it. We're going to expand the brackets, and I'm going to set them out in a particular way. So x times ax squared is ax cubed. X times bx is bx squared. X times c is cx, and x, and then the d's out here, isn't it? Right, so minus 3 times ax squared is minus 3ax squared. And I'm putting it down here, like I'm writing the x squareds underneath each other. I could write them in a big long line, but this setting out will just make things easier in the long run. Minus 3 times bx, and minus 3 times c. And then I've got a d as well hanging around, okay? Because when I've expanded those brackets, I've got a d to add on. So I'm just going to put a plus d, okay? Now that whole lot there is equal to an x cubed and a 2x squared minus 17x plus 6. So, what have I got? Well, if this thing here is going to be the same as this thing, well, the x cubed term over this side has to be the same as the x cubed term over this side, doesn't it? They both have to be the same. Well, what I'm going to do is I'm going to say, well, the coefficient of the x cubed term here is 1. The coefficient of the x cubed term is here. Here is a. Now, those two things have to be the same. So we're going to do what we call equate coefficients. So a has got to be equal to 1. And that comes from the x cubed term. Okay? The x squared term gives me, well, b minus 3a. Minus 3a is the coefficient of the x squared term over here, and the x squared term over here is 2x squared, okay? The x terms, well, I've got c minus 3b. If I collected the x terms together, that would be the coefficient here, and that's got to be equal to, equal to 2, not to 2x squared. C minus 3b is going to be equal to 17. And then the constant terms here, so the constant terms, or the x to the power of 0 term, if you like, is minus 3c plus d, and that is going to be equal to 6. So what have we got? Well, we've got a equals 1, so we've got a, brilliant. Well, this equation here is b minus 3 lots of 1, so b minus 3 equals 2. So B, it looks like, has got to be a 5. Okay. And then if we take that and we put it in here, we get C minus 15 equals minus 17. So that gives us C is going to equal minus 2. And if C equals minus 2, then 6 plus D equals 6, which tells us that D equals 0, and which we knew already because we've done this with the other method and it turned out there wasn't a remainder. So what have we got? We've got x minus 3 equals ax squared plus bx plus c in brackets and then a plus a d. And we've got a equals 1, b equals 5, c equals minus 2, and d equals 0. So in other words, x minus 3 times x squared plus 5x minus 2 plus nothing equals x cubed plus 2x squared minus 17x plus 6. And there's my answer, same as with the other method. That's the one I prefer. You can feel free to try both of them out, or if you've already tried the bus stop method and you're getting stuck with it, which is why you come to the videos, well, maybe try this one and see if that suits you any better. Both of them work perfectly well. This one, I think, seems more intuitive. You can understand where it's coming from. I think that they are algebraically very equivalent. I think that the fiddliness is the same in both methods, but I know that most people disagree with me and most people prefer the bus stop method. Good luck.